You are.
Okay. Hi everyone, thanks for joining my talk. I'm not sure if you were before in Vittorio's talk, but this is somewhat a continuation of it. I will show you a new component in MySQL Server that is a component for the MySQL REST Service. I'm Miguel, I come from Portugal. Some of you might know me for MySQL Shell, Router, the whole InnoDB cluster and those topologies. But I'm at MySQL for 14 years now. And more recently, I've been working in parallel in this new MySQL REST Service component. So I will show you that today. All right, so setting the stage. I hope this is not repetitive because Vittorio already gave a very nice presentation, but just quickly, I would like to say why REST access matters today, or rather still matters today. And you know, tons of web applications, continuous integration, tooling, monitoring tooling, and so on. They speak HTTP, they exchange JSON between themselves. So REST didn't win because it's perfect, it's not, but it won because it's everywhere. It still is nowadays. So applications expect this seamless integration. So there's this stateless access with using HTTP and exchanging JSON. And like Vittorio was saying, then there is this, how did you call it, middleware tax? Middleware monster. So applications have to, and teams have to build layers between the database and the applications to translate and handle REST. So there's a lot of custom serialization, validation, extra services to deploy and operate. So this whole layering and this whole monoliths and this middleware tax. So the question is, why should REST always live outside the database? So the database is the database. SQL is used to talk to the database. But then REST became this common language to talk between, like I was saying before. So why should REST be outside of the database? And that is exactly the main goal of this MySQL REST Service, also known as MRS, that is much shorter. And there's this very nice sentence, I don't know who wrote it, maybe it was you, Mike, or I don't know. It's very nice, and it says that REST Service is a next-generation JSON Document Store solution that enables fast and secure HTTP REST access to MySQL data. So, in general, this REST service exposes data from MySQL, from tables, views, store procedures, functions to MySQL data through REST. So it's designed for HTTP and JSON access to the data in MySQL. So ultimately, it provides SQL-free access to the clients. So it follows, for those who are familiar with, the Oracle REST data services follow similar design principles. It was initially developed and it is available at the moment through middleware, that is MySQL Router, that is a very known middleware, and I think everyone is familiar with it. So no new middleware, it's MySQL Router, and it's also available as part of the cloud service MySQL Gateway. So, what was the goal of this project that I've been working on lately? It was to bring this solution into the server directly, so not through middleware. Don't take me wrong, there's nothing wrong with middleware, there's nothing wrong with Router. It delivered very well many things. So as a start, there's a clear separation of concerns. So you have MySQL Server, you have the router, you have your clients. And this was built on a proven HTTP and REST stack of MySQL Router. I don't know if you're familiar with it, but Router exposes also a REST API. There's this HTTP and REST stack. Like it was said before, you can horizontally scale by adding as many routers as you wish in your topology. And the most important thing is that Router is one of the key components of the solutions of MySQL database architectures. So InnoDB cluster, replica set, cluster set. Router is there if you deploy those topologies. So now you can have both your entry point from the clients to route your queries to the database architectures, but also have REST in Router. You just have to enable it. So this allowed enabling this REST access without modifying MySQL Server directly. So fast experimentation, much faster development, and iteration. So this was all great. There's nothing wrong with it. It will remain there. But what will become if we move this into the server directly? We will have REST available without MySQL Router. That's the obvious reason, right? So reduced operational setup. One less thing to operate, configure, monitor, and whatnot. And then we have access to multiple things, such as the native authentication and authorization of MySQL itself, unify the management of certificates for TLS, and direct access to multiple servers, services such as keyring, because, for example, Router has its own keyring, that is yet another binary, but the server has a keyring service. There's a keyring API, so we can have direct access to that. sysvars, status vars, UDF-based control, and so on. I will go into detail about all of those. And it's a single lifecycle model for startup and shutdown. All right, just to be clear, we wanted REST for standalone MySQL and not just on LineaDB cluster. So this, it's a summary. It's no cluster or router required for those who just deploy a standalone MySQL and want to try this solution. They don't require a router or any topology. And you get the same REST capabilities for single node MySQL, so we believe that this allows a much, much lower barrier to adoption. So anyone can easily deploy MySQL and just install this component and have REST in the server directly. Now, again, the hot topic, that is extensibility in MySQL. How did we do this? We obviously didn't change MySQL code directly, the core, we just extended it. So the extension nowadays is using the components infrastructure. Before, I think until this was, I'm not sure, it was introduced in 8.0, I think. Before were plugins. But plugins are different than components. Plugins are essentially hooks in the MySQL Server code. There's a strong dependency on the headers libraries. It's harder to track. It's easier to break things. So the components were built to overcome many of those problems. So components are a service-oriented architecture. Producers, there's a registry, and consumers. How does that work? There's a, I don't know if that is, you can see it. So every component is a module, a shared library, that implements one or multiple services, or loads services already existing. And then there is a registry that will register the services in use. So there's a reference counting. So if you have multiple components loaded, and they are using the same services, the registry makes sure that you're not going to unload a service that is being used by other components. So it's safer. Then there is a dynamic loader that loads and unloads a component, and this is based on a library called the libmin chassis. This library, in theory, is independent of the server, so you can have components built in a different binary that is not the server. So this whole architecture allows a modular code. Things are more modular and can be reused. And then the services, what they do is to define APIs. So they define contracts. The registry is type agnostic. It doesn't care for what the implementation of those APIs, only cares that for what they expose, the API itself. And there's no server interference in component-to-component communication. So it's more separate. So, like I said before, there's a strong dependency tracking. So this ensures safer and explicit dependencies. And 3 sentences to summarize: explicit contracts, predictable behavior, safer extensibility. It's not perfect, but it's much better than plugins. So this is what we used to do this MRS component. So, going a bit into to talk about the architecture of the component itself. This is a very, very, very high-level overview of the architecture. So this is on left, the high-level request lifecycle. So MySQL with a component loaded is exposing an HTTP port alongside the other SQL or ports, or if you're using. So one thing is that when you load the component, if you're using the X plugin, the X protocol, that is shut down, and the same port is going to be reused for HTTP for this MRS service. Now, when a request from an application, an HTTP request comes in to the HTTP port that server is exposing, the endpoints are resolved by the MRS itself. Then authorization happens using MySQL users and privileges. Data access is executed by the server, and then the MRS builds and responds JSON back to the client. Yes?
Question, when on step 4, when you are talking about data access, in this case, the component issuing query using table access service, or is it?
At the moment, both.
Okay.
In the future, the plan is to access directly without queries for performance reasons.
So you will access the.
But this is
the
still
storage
labs.
Yeah. Storage entity?
Yeah.
So you're going to go to the lower levels directly when you can, maybe not now, but you're planning
Yes.
to go deep inside. and
Yes,
get
exactly.
Much better.
Exactly.
Performance.
That's the goal. Yeah. So inside MySQL the single process, there's a component loaded handling HTTP, the REST logic, and there's a metadata-driven routing. And the component itself uses multiple services. I will go through them in a bit. So authentication, schema access, the keyring that I showed before. It manages the certificates, TLS, SSL, then uses sysvars and UDF-based control and many other things. Okay, so how we built this thing? What was the engineering journey to build this component? Just very high level, we started at prototyping, hitting my head against the keyboard with plugins, then moving to components. Creating the boilerplate for a new component, reusing router code, because we don't want to reinvent the wheel, nor keep two branches of the same thing. Integration with all the services of server, then there were many hard parts along the way, and then in the end, the stabilization until we reached a point that we could release as a labs this thing. So the milestones were the component foundation, create a component with a proper life cycle, reusing the router code. So router is, I don't know if you're familiar with it, but router has a chassis and a loader and multiple plugins. So the loader loads those plugins. Those plugins are HTTP, IO, MRS, that is the REST service, then the metadata cache plugin to handle the big cluster and those topologies. And we wanted to reuse some of those plugins that implement the MRS logic, and that was a challenge. Then the third milestone was logging integration. So as you know, router is a different binary. It has its own logging system. Things are different files and whatnot, but since we now live in the server, we had to use the server's logging framework. Configuration model. This was another challenge because router operates using its own configuration files. And in the server, for obvious reasons, we didn't want to add things to the configuration file. We wanted to configure it using sysvars and then status vars as well to check things. Security and accounts use all the proven stack of MySQL of users, privileges, certificates, keyring, automatically create and manage the internal MRS accounts, so users have it easy, because usability, as usual in our group, has top priority. Bootstrapping, so as you know, router, when you deploy router, you need to bootstrap it against the server, the topology. Bootstrapping means to run this binary that instructs router to connect to an instance of the topology. Router will fetch the information needed, will register itself in the metadata schema, will reconfigure itself, and so on. But in the server, we wanted to do this automatically. So no running extra applications or whatever, or extra steps to do this bootstrapping. Then remove router-specific assumptions about many things. users, routers layouts, assumptions. And finally, have this full and clean startup and shutdown life cycle, proper packaging to all the supported architectures that we support, and a full MTR test coverage for this new functionality. A little bit more into detail about the architecture. This is not UML, of course. So on top there's a component code, the skeleton. The component is a central orchestrator. It will, it has an init and a shutdown methods. Those are the main entry points to start and stop. And when init is called, when you load the component, it will start the backend. The backend is the actual engine running the REST service. It manages threads because we spawn threads for multiple things. I will talk about it. And it handles the lifecycle, then the metadata access and whatnot. And then we have multiple structs to do mapping of the things needed by the router plugins to all things are done in the server. So for example, the configuration. There's this struct that stores the configuration needed by some router plugins that is then translated into system variables. Then the current security context, MRS accounts for handling credentials, and then the component using multiple services implements multiple classes to handle the system variables that we expose, the status variables as well, server configuration to retrieve and process server settings that we need. It exposes UDFs. At the moment we only have 3. One to start, one to stop, and one to restart. As things evolve, we'll probably have more UDFs. That's the way to control the component. The keyring handler. This was is the class to use the keyring service for components to handle the keyring in the component in our component. The logger, and then multiple things. For example, the table accessor, where you were asking before, we already have some things using this table accessor, so we go directly to the server. For example, to query performance schema. So instead of doing a query, we just access it directly. So this is an entry point for the future improvements. Then the command executor to execute queries and prepared statements. That is both THD aware or you can use explicit context. So in MySQL, when a session comes in, there's this structure called THD. There's a new thread created. This THD holds information about the session, credentials, and whatnot. So we can execute commands using that. So for example, when you do install component, you still have access to that. But as soon as a thread is spawned, we lose context.
So do you have, are you using the thread pool plugin on
No.
or you're not?
No.
So is one HTTP connection to one thread and server at the moment?
Yes.
Okay.
Miguel, question, sorry. If you need to get multiple objects, one request, can you do like a transaction across the request, or for now it's just one request of a commit kind of thing?
Yes. For now, yes.
For now?
And can different users see different views? Because you might go, I'm an admin, I want to see more information, and someone else is a user, they see less information on the same theory, the same data set or table or something. Or is that not really something that's...
No, this is not, yeah, I will discuss that later if you want on the...
In your talk?
But not completely like that, but it's, what you can see, it's about the user that use the REST
different
service.
users can see different views of things, basically?
Yes.
Okay, that's fine.
Sorry, I wasn't understanding your question. Do I only have 5 minutes here?
Yeah, mine is in 5 minutes,
Okay.
but you,
I think I have more
you have
time.
more time because you started late, but I mean,
Okay. Don't scare me.
I want to show you, okay,
Okay.
area.
Okay, anyway. Yeah. So in this table, I'm just showing a list of services used by the component. In case you're interested, the code is, we released in labs, so the code is open source, it's available. Eventually we'll go into the server tree. And this is the internal area that I was talking before, maps to those classes, and those classes use those services. We use many services. I hit many bugs that I had to fix because I believe that nobody used those things in such an extensive way like I did. And we had to extend other services, so that's just a general list of things used. Okay, so hard parts. I've already spoken about some of the hard parts along the way. Just some challenges we hit. First one, component boundaries differ from plugins. This is not really a problem, it's just we had to adapt to a different mindset, that's all. Like I was saying, threads inside components lose the THD context. We spawn some threads, so we lose the context, and we cannot get, for example, the security context to execute things inside threads. The logging needed the bridging to the logging of router. Router assumptions don't hold inside MySQL, of course. For example, router uses the live MySQL client for queries that don't have direct access to tables and so on. We had to change the way TLS is handled, so we ensure that we use the certificate handling of the server. And this was an interesting one because if you're familiar with MRS, you need to configure and create a schema, MRS schema, like you were asking for, Simon. And that might not exist at startup. So what will we do? Just install it, you load the component and you error out to the client saying no metadata, cannot do anything. No, that's bad usability. So what we did was to spawn a thread. The thread tries to check for the schema every 30 seconds, if I remember correctly, and it's just there. It just logs an informational message in the log, waiting for the schema. As soon as it detects the schema, the backend starts, another thread is spawned, it does all the bootstrapping, all the configuration, everything is automatic. It will use the sysvars that you configured or the default values, and then we'll spawn another thread to run the REST service itself. So design consequences, asynchronous backend initialization. We had to implement a custom query execution to use the security context stored in the keyring. The deferred init checks for metadata that I just was speaking about. Changing from the router way of using certificates to the server way. And then change the way things are configured and controlled. I already spoke about it. Not use files or clients, just rely on sysvars and UDFs. And have a safe life cycle for shutdown and startup with proper error and explicit error paths. In the end, well, it's not the end, but when we released the first labs version, what we achieved was that we have the component running inside MySQL Server. So MySQL is acting as an HTTP server. Sounds scary, but it's not because everything is controlled. It's built on the MySQL components. It's secure by default. It's using the well-proven MySQL Server security things. And like I was saying, it's operational ready. You can configure it and control it with sysvars, UDFs, automatic bootstrap and metadata registration. Has a full MTR test coverage, so we could release it as labs. We believe that this is a foundation, just not a new feature, so a foundation for future, hopefully, server capabilities. To close, and some things on the roadmap, we need to, before we can actually release this as GA, we need to add instrumentation. So everything in performance schema, that's a challenge, it will take some time. Before someone, I think it was Simon, that you asked about throttling, about the we have it already, but we need to improve it, to add more configuration over it.
But that would also be useful in the server, because right now...
It is, because you have an HTTP port, you need to...
No, for SQL queries, because there isn't a good throttling mechanism for users overusing the resources.
Yeah.
So maybe if what you have there, maybe you can extend it so it could be used back in the
Right.
service.
Right.
Essentially.
Right.
So if there's a way to control, to limit the connections.
Yes. The HTTP connections. That's where
We have some stuff like that already in the new thread pool in enterprise. That you
But
can
that's,
also dynamically say, I want to, this user has less, this user has more, or
Okay.
so.
I didn't know that. Okay. We want to improve rotation for certificates. Some improvements on what Mike said before about this development and production modes. We want to add some CSVs for the metadata schema itself, so we don't have to query the schema directly. And eventually, we want to add support for MySQL database architectures. Maybe you're wondering why, because there's router itself does that, and when you deploy an in-memory cluster, you have routers. But maybe you want to deploy a cluster and not use it for the classic use case of the in-memory cluster. Maybe you want a cluster just for MRS. So in that case, you don't need router, you just use the component. And another thing is that the SQL extensions for this REST service that you can use at the moment only in MySQL shell, we want to eventually add it to the server directly. So this will allow richer REST APIs, better management or easier management for endpoints. And at the end, to have REST as a first-class server interface. So like I was saying, foundation for future server capabilities. As for the community, as usual, I invite everyone to speak.
Final question, is there
Yeah.
any plans to perhaps use gRPC to allow you to, because JSON's extremely inefficient, and maybe that might allow,
That will be
or
a-
is that not something that's
No.
not come up, or no one's answering, no one
No.
cares?
Can you elaborate a little bit on what the current plans or ideas are for supporting different architectures? Because mostly I'm worried about
Different?
figuring out who is the primary.
Yeah, exactly. This is going to take a while. There's many challenges to tackle. So
Can you share what the plans are, ideas are, or is it still in discussion?
no, it's still under discussion. It's not a priority. The priority right now is this, the three first ones. That's a priority. We need that to be able to release in as GA. What I was saying. Oh, of course, I invite feedback from everyone. You know that I'm always in Slack and available and open to discuss. We want to validate real use cases, and let's shape together what comes next. So try it. It's some labs. We released on Wednesday, right? The 9.6 version. So the component is now rebased on 9.6 and has already the keyring that I spoke before. It's using the keyring from the server. And the code is there, so you can also look at the code if you'd like. And that's it.